Hey guys, so here's the notes for 1.7 day 2. We're going to be talking about solving absolute value inequalities. Now, when we solve absolute value inequalities, it's going to be similar to how we solved absolute value equations. We're going to create two, in this case, inequalities, okay, and solve them. But we also have to do some extra things. We will have to display our solution on a number line and write our solution in interval notation. Okay, so let's talk about when we did absolute value equations. Basically, if you only had a variable on one side, you had two solutions, right? So you would have, in this case, notice we have the absolute value of x equals 3. So basically, the two solutions would be 3 and negative 3, because negative 3 is 3 units away from 0, and positive 3 is 3 units away from 0. So the distance from 0 is 3. Okay, so when we did absolute value equations, we could have, no solutions, two solutions, or one solution. Now, with absolute value inequalities, though, this is going to be a range of solutions, okay? So like here, the distance from 0 is less than 3. So that could be like less than, and it depends on what we have. So if it's an and, it could be anything in between. So you basically want to figure out, well, what numbers will work, okay? And remember, you're taking the absolute value of it. So like if we plug negative 2 into there, so we did the absolute value of negative 2, that gives us positive 2, and 2 is still less than 3. So when we do inequalities, we are going to have a range of solutions. So that means we are going to have to write this in interval notation to really represent it, and do it on a number line as well, okay? So when we have values less than, that just means we have a multitude of values, or we could have greater than, and of course, once again, a multitude of values. Okay. So then let's talk about the shading. So when we have the less than sign, so that could be less than or equal to, or just a less than, this is what I like to call an and problem. So when we shade on the number line, that means with an and problem, we're going to shade between the two numbers. So we solve, we get the two numbers, and we shade in between, okay? So this is the less than, so that's a way to say this is an and problem and which way to shade, okay? So less than, so it's an and problem and we shade in between. We could also have an or problem. So this is when we have a greater than. So this could be greater than or equal to, or just a greater than. What happens here is you solve for your 2, and we will shade opposite sides, so they go away from each other. Now, how am I going to remember this is an or problem? Is when we think of greater. Okay, so anything you see greater, we shade opposite directions. Okay. Okay, so now let's talk about interval notation and all that stuff. So when we did interval notation, we kind of already talked about the ideas of parentheses and brackets, okay? So with parentheses, that means it is not equal. So that means if our number's not equal, or if we have infinity signs, we also use parentheses. So we did that when we did our domain and range as well. So we use parentheses anytime anything is not equal, so that could be the less than or the greater than sign, and when we use infinity symbols. Now, when we do our, on the number line, let's talk about what happens with our circles, because this is going to go back to when we did piecewise functions and when we had open and closed circles. So circles on the number line. Okay, so if we have parentheses meaning not equal, that means we are going to have an open circle, just like when we did piecewise functions. Okay. Now, if we have the equal bar, that means we'll use brackets, okay, and that's going to be around the numbers. So we saw that when we did our range, and we always used a bracket around the number. So that means we are going to have a closed circle on our number line. Okay. So union means and, that just means we are going to kind of combine things. We will see this when we have the greater than type of problems. And then negative infinity and positive infinity, of course, we're going to see those as we did when we did our domain and range. And remember, negative infinity is the smallest, infinity is the largest. And anytime we write in interval notation, we always write from smallest to largest. So you might want to write that down so we remember, because that's what we also did when we did interval notation for domain and range. Always go from smallest to largest. Okay, let's do a couple of problems together so we can really use all this information here. Okay, so we're going to solve each inequality, graph the solution on a number line, and then write our solution in interval notation. So our first one is we have the absolute value of x less than 5. Okay, so here we need to create our two inequalities. So to do that, once again, just kind of like with our absolute value equations, I get rid of the absolute value bar. So I have x is less than 5. Okay. Now on our other one, what we're going to do is we're going to write our second, and what happens is we negate the 5 and we flip the inequality sign. Okay, so that means we get x is greater than negative 5. Okay, so we need to decide if this is going to be an and or an or problem, because that allows us to know if we're going to shade in between or opposite directions. Well, since this is a less than, this is an and problem. Okay, so that means we're going to shade in between. So once we have our two inequalities, we solve for the variable. Well, our variable's already solved for, so that's great. So here we're going to shade in between. Now the thing is, with our less than, we could also write this as what is called a compound inequality. Because the idea is that with the less than, we have things in between 5 and negative 5. So another way of writing this is we have negative 5 is less than x, which is less than positive 5. So what this is representing is that we can have all numbers in between negative 5 and 5, and they will work. That's why we can shade in between, okay? Okay, so when we go back, when we do our less than problems, I want us to write it as a compound inequality. So we will have negative 5 less than x, which is less than 5. Okay. Okay, now we can go ahead and do our number line. So we have negative 5 and 5. Remember, on our number line, we should be going from smallest to largest, okay? And so you have that. You just want to make sure that 0 is like in between, okay? Okay, now we need to decide, do we have open or closed circles? Well, since there's no equal bar, we're going to have open circles. And as we said, we're going to shade in between because it's an and problem. Boop, 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 boop. Okay? And that's all you need to do. So now we're going to go ahead and write our interval notation. So notice we go from negative 5 to 5. This is a segment. Think about when we did piecewise functions. Okay? So with segments, we have a starting and a stopping point. So with our starting, we do there. Now, because we have open circles, do we use parentheses or brackets? We will use parentheses. So I go from negative 5, and then I go to my stopping point, positive 5. And once again, since it's an open circle, we have parentheses. So there's my interval notation. Okay, let's go ahead and do the next one. So number 2, we have the absolute value of x greater than or equal to 1. Okay, so with this, we need to identify, is this a or an and problem? Well, this is a greater sign. So this is where you really need to know your inequality signs, because that'll help to know if you need to shade opposite directions or in between. So since this is or, we will create two inequalities. So I have x is greater than 1, or x is less than or equal to negative 1. Okay? So from there, I try to solve for x. X is already solved for, so I'm good to go. So now I do my number line first. So I put 1 and -1. So I have -1. We know zeros in between, and then 1. Okay? So now I need to decide, do I have open or closed circles? Well, since I have an equal bar on my inequality, both of them are closed. Yeah. So the nice part is for your points, either both of them are going to be open or both are going to be closed. You don't need to do either or. Now, because we know this is an or, we're going to shade opposite direction. Room to write that. Okay, so that means I just go to the opposite side. So I go ooh and boo. That's it. So nothing in between. Now let's talk about this interval notation because this is going to look very different. This is where we're going to use the union sign. So notice that when I shade opposite directions, this actually will go on forever. So to represent forever, we use infinity signs. Now going to the left represents going to negative infinity because those values are getting smaller. So I go from negative infinity to my first solid point, which is at -1. Because that's solid, I'm going to use a bracket. Now I need to represent the other half of our number line. So this is where I use my union, and I start back up at 1. So I do bracket 1 and then infinity. Because when we go to the right-hand side, that means we're going on to positive infinity, or we're increasing forever there. Okay. Okay, so we're going to go ahead and do more problems, and make sure you guys watch those parts of the video.